Good morning, students. In the last class, we are discussing about the magnetic field. So, when a charge moving with some velocity, so along with that electric field, so magnetic field is also produced. So that force we call as the Lorentz force, right? So that we written as F is equals to Q into E plus V cross B. So this gives what the Lorentz force, right? So where Q into E, we call that one as the electric force, plus Q into V cross B, we call that one as the magnetic force. Right? So we are discussing about the magnetic force F, magnetic force, that is equals to Q into V cross B. Right? So in the last class also we discussed about when the magnetic force is maximum and when the magnetic force is minimum. Right? So we can also write this one as F magnetic, that is equals to QVB sin theta into n cap, where n cap gives the direction of the force, right? So this is from the definition of the cross product. So when we get the magnetic force is maximum when theta is equals to 90 degree, we get the magnetic force that is maximum, that is QVB. We call this one as maximum, right? So when we get the magnetic force is minimum when theta value is 0 degree or 180 degree. That means the angle between the velocity of the charge and to that of the magnetic field is both in parallel or in anti-parallel. That means 0 degree or 180 degree. So we get the magnetic force that is 0. We call this one as minimum. Right? So other than values which is ranging between 0 and 90 degree, we get the magnetic force QVB sin theta, and force direction is always perpendicular to that of the magnetic field, or it may be perpendicular to that of the velocity of the charged particle. Right? So SI unit of magnetic field. Right? So when a force is acting on a unit charge, so that means the charge value is 1 coulomb. When force is acting on unit charge moving with speed 1 meter per second in the direction perpendicular to magnetic field is 1 Newton, right? So this gives what the magnitude of the magnetic field. So magnitude of the magnetic field is 1 unit when we say that when force is acting on unit charge. That means the charge value is 1 coulomb and it is moving with a speed 1 meter per second and it is perpendicular to the direction of the magnetic field, right? So perpendicular to the direction of magnetic field means when theta value is 0 degree, right? So from this equation we need to find the unit of magnetic field. So rearranging this equation, B that is equals to F divided by QV, right? So from this definition we can write, so force acting on the charge is 1 Newton, right? So 1 Newton divided by the force which is acting on unit charge is 1 coulomb and that charge is moving with a speed 1 meter per second, right? So we get the magnitude of the magnetic field is 1 unit, that is equals to 1 Newton second per coulomb meter. Right? So we call this unit as Tesla. That means Tesla is the unit for the magnetic field. So SI unit of the magnetic field is Tesla. So in letters we can represent that with the capital letter, right? So this is the definition for the Tesla. So define Tesla means when a force is acting on a unit charge moving with a speed 1 meter per second and is perpendicular to the direction of the magnetic field is 1 Newton. That means all the values should be 1. So force acting on the charge particle is 1 Newton. So the charge is unit charge, that means 1 coulomb. So it is moving with a velocity 1 meter per second. So 1 divided by 1 into 1, again we getting 1, right? So the unit of the magnetic field, we call that as Tesla. As Tesla is the larger unit, so Tesla is the larger unit is there. So for measuring the magnetic field, we use a non-SI unit to measure the magnetic field, so that we call the Gauss, right? So 1 Gauss is equals to 10 to the power of minus 4 Tesla, right? So namge exam alli mention write the SI unit for the magnetic field andre you need to write the Tesla, not the Gauss. So Gauss is a non-SI unit. So Tesla unit jasti value jasti irodrinda to measure the magnetic field we use the another unit, so that unit we call the Gauss, right? So Gauss is also the unit to measure the magnetic field, but it is not a SI unit, right? So 1 Gauss is equals to 10 to the power of minus 4 Tesla. So in case problems Gauss value potential, always we need to convert that into the Tesla, right? So you need to remember this value. 1 Gauss is equals to 10 power minus 4 Tesla, right? So Tesla is the unit of the magnetic field, right? So here one convention we are using. So ray optics ಅಲ್ಲಿ ಯಾವ ತರ ನಾವು sign conventions ಅಂತ ಯೂಸ್ ಮಾಡಿದ್ವೋ ಇಲ್ಲಿ ಕೂಡ ನಾವು convention ನ ಯೂಸ್ ಮಾಡ್ಕೊಳ್ತಾ ಇದೀವಿ. So if consider this one as one plain paper, right? So if the current or field is moving into the plane of the paper, so ಇದು ಒಂದು ಬೋರ್ಡ್ ಇದೆ ಅಂದ್ರೆ ಈ ಬೋರ್ಡ್ ಒಳಗಡೆಗೆ ನಮಗೆ ಏನಾದರೂ ಕರೆಂಟ್ ಫ್ಲೋ ಇನ್ ದಿಸ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇಂಟು ದ ಬೋರ್ಡ್ ಗೆ ಕರೆಂಟ್ ಏನಾದರೂ ಫ್ಲೋ ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಅಥವಾ ಫೀಲ್ಡ್ ಏನಾದರೂ ಆ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಫ್ಲೋ ಆಗ್ತಿದೆ ಅಂದ್ರೆ so that we are represented by cross mark, right? So this is the conductor. So current I, so which is flowing into the paper. So paper ಒಳಗಡೆ ಏನಾದರೂ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತಿದೆ. So ಇದು ಜಸ್ಟ್ ರೆಫರೆನ್ಸ್ ಆಗಿ ತಗೊಳ್ತಾ ಇರೋದು. So paper considering as one plane. So ಈ plane ಗೆ inside current. So plane ಒಳಗಡೆ ಏನಾದರೂ ಕರೆಂಟ್ ಹೋಗ್ತಾ ಇದೆ ಅಂದ್ರೆ so that we represented by the circle with into mark, right? So either it may be current or it may be field, right? So magnetic field kuda e direction alli flow aagta ide, that means inside the plane of the paper or into this board. So ಒಳಗಡೆ ಏನಾದರೂ ಹೋಗ್ತಾ ಇದೆ ಅಂದ್ರೆ so current ಅಥವಾ field we represented by the cross mark with the circle. So ಒಂದು circle ನ ಡ್ರಾ ಮಾಡ್ಕೊಂಡು cross mark ನ ಬರ್ದಿದೀವಿ ಅಂದ್ರೆ it indicates what the current is moving inside the board or inside the plane of the paper, right? So the another one is first one, second one. So the current or magnetic field which is coming outside towards emerging out towards the us. So ನಮಗೆ ಈ ಬೋರ್ಡ್ ಇಂದ ಹೊರಗಡೆ ಕರೆಂಟ್ ಬರ್ತಾ ಇದೆ ಅಂದ್ರೆ ಅಥವಾ ಬೋರ್ಡ್ ಇಂದ ಹೊರಗಡೆಗೆ ಫೀಲ್ಡ್ ಬರ್ತಾ ಇದೆ ಅಂದ್ರೆ so ಅದನ್ನ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ಕೊಳ್ಳೋದು ಯಾವ ತರ ಅಂದ್ರೆ ಸರ್ಕಲ್ ಬರೆದ್ಬಿಟ್ಟು inside if it represents the dot. So this indicates what the current is coming outwards, that is emerging outward from the plane of the paper. So this is the current which is flowing inside the plane of the paper or into the board. So board ಒಳಗಡೆ ಕರೆಂಟ್ ಹೋಗ್ತಾ ಇದೆ. So ಈ ಕೇಸ್ ಅಲ್ಲಿ ಬೋರ್ಡ್ ಇಂದ ಹೊರಗಡೆಗೆ ಕರೆಂಟ್ ಬರ್ತಾ ಇದೆ, right? So this is the conductor current I which is coming out from this plane of the paper, right? So that we can represent it by a circle with the dot mark or so current ಇರಬಹುದು ಅಥವಾ field ಇರಬಹುದು, magnetic field B, right? So that is represented by a circle with the dot mark, right? So these are the conventions. So maximum we are using the cross and dot. So it indicates what the current is flowing inside the board and coming outside the board, right? So this convention we are using in this chapter. So next topic, magnetic force on a current carrying conductor. Magnetic force on a current carrying conductor. Right? So consider one rod of uniform cross section of area A and length L. Right? So consider one rod of uniform cross section area. Uniform cross section area means at each and every point the cross sectional area of the rod is remains same. So that we call as the uniform cross sectional area. So consider one rod of length L. So we taken this one as length L, right? So it has a uniform cross section area A. With A is the area of the cross section, right? The area of cross section, L is the length of the rod. So in this rod, I is the current which is flowing, right? Current flowing in the conductor. So rod ಅಂತ convention ಮಾಡ್ಕೊಂತೀವಿ ಅಥವಾ conductor. So consider a conductor of uniform cross-sectional area having the length L and I is the current which is flowing in the conductor. So when an external magnetic field is applied, so this indicates what? The magnetic field moving inside the plane, right? This indicates the magnetic field that is external. So we are going to observe what happens when the conductor is placed in an external magnetic field. So that is the derivation we are going to derive, right? So magnetic force on a current carrying conductor. For this, initially consider one conductor or rod having the length L and uniform area of cross section is A and I is the current flowing in the conductor, right? So current flow ಆಗ್ತಿದೆ, so there are the charge carriers. So current is defined as rate of change of charges, that is dq by dt. That means conductor directly we can write current carrying conductor having mobile charge carriers. One kind of mobile charge carriers. So current flow ಆಗ್ತಿದೆ ಅಂದ್ರೆ it carries a current. So ಇಲ್ಲಿ ನಾವು conductor ಅಂತ consider ಮಾಡಿರೋದ್ರಿಂದ so mobile charge carriers nothing but the electrons. So electrons are flowing in the conductor or moving in the conductor, right? So let n be the charge density. let n be the charge density, right? So ಇದರಲ್ಲಿ ಎಷ್ಟು ಚಾರ್ಜ್ ಕ್ಯಾರಿಯರ್ಸ್ ಹೋಗ್ತಾ ಇದೆ ಅನ್ನೋದು ನಮಗೆ ಗೊತ್ತಿಲ್ಲ. So directly we can take let n be the charge density, right? So the density, we have charge density n, that is equals to number of charge carriers per unit volume, right? So we can define charge carriers n is equals to the number of charge carriers per unit volume. So here we need to find the number of charge carriers which are flowing in the conductor, right? So number of charge carriers in the conductor, that is equals to n into volume, right? So where n is the charge density and volume of the conductor, right? So volume, we have the formula n into volume is length into area of cross section, right? So that is A into L, right? So here the charge carriers are the electrons, right? So Q is equals to NaL into E, right? So because the conductor carry the electron, so ಇಲ್ಲಿ ನಾವು conductor ಅಂತ consider ಮಾಡೋದ್ರಿಂದ charge carriers electrons ಇರುತ್ತೆ. If we consider this one as semiconductor, that means it has both the electrons and holes, right? So electrolytes ಅಂತ consider ಮಾಡಿದ್ರೆ ions ಇರ್ತಿತ್ತು. So ಇಲ್ಲಿ ನಾವು conductor consider ಮಾಡೋದ್ರಿಂದ only the electrons are flowing, right? So these charge carriers or electrons moving with a velocity, that velocity is the drift velocity, right? So charges ಏನಾಗ್ತಿದೆ ನಮಗೆ move ಆಗ್ತಾ ಇದೆ. So as the charges are moving means it has the velocity. So we taken the average velocity of the charge carrier, so that velocity we call as the drift velocity, right? The electrons moving with the velocity, so that velocity is the Vd, right? So Vd is the drift velocity. So now last chapter current electricity ಅಲ್ಲಿ study ಮಾಡಿದ್ವಿ. So conductor ಅಲ್ಲಿ charges move ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ it collides with the neighboring atoms. So average velocity of the before collision ತಗೊಳ್ಳೋದನ್ನ ನಾವೇನಂತ ಕರೀತಿದೀವಿ, drift velocity, right? So Vd is the drift velocity. So charges move ಆಗ್ತಿದೆ ಅಂದ್ರೆ again there should be a magnetic field. So magnetic field ಇದೆ ಅಂದ್ರೆ force is produced on this conductor, right? So last class ಅಲ್ಲಿ ನಾವು explain ಮಾಡಿದ್ವಿ, that is F is equals to Q into V cross B. So ಇಲ್ಲಿ ನಮಗೆ magnetic field ಇದೆ, that is the external magnetic field, and also the charges are moving with a velocity, that is the drift velocity, and we have the charges. So all these terms which are present in the current carrying conductor, so hence the conductor experiences a force, right? So that is the force which is experienced by the current carrying conductor, right? So we can write the force which is experienced by the current carrying conductor F, that is equals to Q into Vd cross B, right? So this is from the definition of the magnetic force, right? So the force which is experienced by the current carrying conductor, that is equals to Q into V. In place of V, we are written Vd, where Vd is the drift velocity of the electrons which are flowing or moving inside the conductor, right? So this substitute the value of Q here, so that is NaLe into Vd cross B, right? So again from the current electricity we derive one relation, the current which is flowing in the conductor I, that is equals to NeaVd. So this is the relation for the drift velocity and to that of the current. So ಇದನ್ನು ಕೂಡ ನಾವು current electricity ಅಲ್ಲಿ derive ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ, right? So now observe here NaEVd. So we can replace these terms with the current I, right? That is I into L cross B. So this gives what? The force which is experienced by the current carrying conductor F, that is equals to I into L cross B. Because I is not a vector, so we are just shifting the vector from velocity to the length. So length vector is in the direction of the magnetic field. So we call this one as the length vector. So this is similar to that of the area vector, right? So now previous Gauss laws now derive ಮಾಡ್ಕೋಬೇಕಾದ್ರೆ delta A ಅಥವಾ delta S, we call that one as the area vector. So here we taken that is shifting the vector from velocity to the length, right? So this is the force which is experienced by the current carrying conductor. So 3 marks get tumba important, right? So force which is experienced by the current carrying conductor, we given F is equals to I into L cross B, right? So this again we can write F is equals to B I L sin theta into L cap. Again from the definition of the cross product, right? So L cross B we can written as LB sin theta into N cap. So LB into I, directly we can write F is equals to BIL sin theta. So this is the force which is experienced by the current carrying conductor in an external field. So external field idaga. So ಯಾವುದಾದರೂ ಒಂದು ಕಂಡಕ್ಟರ್ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತಿತ್ತು ಅಂದ್ರೆ ಕಂಡಕ್ಟರ್ ಅಲ್ಲಿ it experiences the force, right? So that force value is equals to BIL sin theta. Now when should the force is maximum? So if force yaವಾಗ ನಮಗೆ maximum ಇರುತ್ತೆ? So when the angle theta between the length and to that of the magnetic field is 90 degree, then the force is maximum, right? So F is maximum, that means BIL, that is theta is equals to 90 degree. Where theta is the angle between the magnetic field B and to the length vector. So ಈ magnetic field ಮತ್ತೆ ಈ length vector ಮಧ್ಯದಲ್ಲಿ ಏನು angle ಇರುತ್ತೋ ಅದು 90 ಡಿಗ್ರಿ ಇದ್ರೆ ನಮಗೆ force ಏನಿರುತ್ತೆ maximum ಇರುತ್ತೆ, right? So F is minimum, that means minimum means its value is 0 when theta is either 0 degree or 180 degree, right? So theta value 0 is on sin 0 0. So 0 into this term again we getting 0. So 180 means again 0. Sin 180 is 0. So 0 into this term we get the 0. So force is minimum when theta is equals to 0 degree or 180 degree, and force is maximum when theta is equals to 90 degree. So this is the force which is experienced when a conductor which is carrying the current, right? So this is the force. F is equals to QVP sin theta into L cap, and F is equals to BIL sin theta L external magnetic field. So ಎರಡು ಕೂಡ external magnetic field ಅಲ್ಲೇ ಪ್ಲೇಸ್ ಮಾಡಿರೋದು. ಸೊ ಒಂದ್ ಏನಾಗ್ತಿದೆ, ಚಾರ್ಜ್ ಮೂವ್ ಆಗ್ತಿದೆ. ಸೊ ಇನ್ನೊಂದ್ರಲ್ಲಿ ಏನಿದೆ, ಕಂಡಕ್ಟರ್ ನ ಪ್ಲೇಸ್ ಮಾಡಿದ್ವಿ. ಸೊ ಕಂಡಕ್ಟರ್ which is placed in an external magnetic field. So this is the force which is experienced by this conductor. So ಇದು ಈ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಫೋರ್ಸ್ ಇರಬಹುದು ಅಥವಾ ರಿಪಲ್ಸಿವ್ ಆಗಿ ಇರಬಹುದು. ಸೊ ಫೋರ್ಸ್ ಅಟ್ರಾಕ್ಟ್ ಆಗಬಹುದು ಅಥವಾ ಫೋರ್ಸ್ ರಿಪಲ್ ಆಗಬಹುದು. ಸೊ ಅದನ್ನ ನಾವು ನೆಕ್ಸ್ಟ್ ಟಾಪಿಕ್ಸ್ ಅಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ, ರೈಟ್? So ತುಂಬಾ important. So don't confuse with F is equals to QEB sin theta and BIL sin theta. Both are the force. So one force is in case of charge and other force in case of current carrying conductor. So ಈ ಎರಡರಲ್ಲೂ ಕೂಡ ನಮಗೆ magnetic field ಇಂದ force produce ಆಗುತ್ತೆ ಅನ್ನೋದನ್ನ explain ಮಾಡ್ತೀವಿ, right? So ತುಂಬಾ important, simple steps ಇದೆ, but ಇದನ್ನ ನೀವು ನೆನಪಿಟ್ಕೊಳ್ಳಬೇಕು. The charge Q. So first chapter ಅಲ್ಲಿ ನಾವು charge Q is equals to Ne ಅಂತ ಬರ್ಕೊಂಡಿದ್ವಿ, where N is a scalar, but here it is moving inside the conductor ಇರೋದ್ರಿಂದ, so we again consider the volume AL, that is NaL into E. So that is the number of charges which are flowing in the conductor, right? So next, motion of a charge in a magnetic field. motion of charge in a magnetic field. So ಇದು ಕೂಡ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ for 3 marks. So in chapter ನಮಗೆ maximum 3 marks ಗೆ 5 marks ಗೆ theory because problems ಇಲ್ದಲೇ ಇರೋದ್ರಿಂದ 10 marks ಗೆ ಚಾಪ್ಟರ್ ಇರೋದ್ರಿಂದ ಆಲ್ಮೋಸ್ಟ್ ಥಿಯರಿ ಎಲ್ಲ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಕವರ್ ಆಗುತ್ತೆ, ರೈಟ್? ಸೊ ಟಾಪಿಕ್ ಹೇಳ್ತಿರೋದಲ್ಲ ಮೋಷನ್ ಆಫ್ ಎ ಚಾರ್ಜ್, ದಟ್ ಇಸ್ ಚಾರ್ಜ್ ಇಸ್ ಮೂವಿಂಗ್ ಇನ್ ಎ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್, ರೈಟ್? ಸೊ ಕನ್ಸಿಡರ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್, that is uniform magnetic field. Right? So namaga formula ide, right? The force experienced by the magnetic, that is charge, F is equals to Q into V cross B, right? So that means V and B are perpendicular to each other, then F is also perpendicular to these two, right? So last class I explain ಮಾಡಿರೋತರ if we consider all the three axes x, y, z axis, because all these three axes are mutually perpendicular to each other, right? So if the charge which is moving along x axis, right, so e directionally move ಆಗ್ತಿದೆ with some velocity v, right? So magnetic field is in the direction of y axis. So e directionally ನಮಗೆ magnetic field ಇದೆ, that means which is parallel to y axis, that means perpendicular to x axis. Then the force experienced by this charge is always in the z axis, because v cross b, that is equals to the force. So eradu perpendicular idare, that force is also perpendicular to these two, right? So y z axis madhe 90 degree idre, x z madhe 90 irutte, so y madhe x madhe 90 irutte. So these are three mutually perpendicular. So when v is perpendicular to b, then F is perpendicular to B and F is perpendicular to B, right? So this is the force which is experienced by the charge. So direction ಯಾವ ಕಡೆ ಇರುತ್ತೆ, along E direction ಅಲ್ಲಿ ನಮಗೆ force act ಆಗ್ತಿರುತ್ತೆ, that is along the Z axis. So ಈ concept ಇಂದ, so here we have the uniform magnetic field along Y axis. So Y axis ಅಲ್ಲಿ ನಾವು uniform magnetic field ನ represent ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ. Then along z axis the charge is moving with some velocity v and that charge having some mass m, right? So p is along y axis, so the charged particle y z. So y axis ಅಲ್ಲಿ ನಮಗೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇದೆ, along z axis ಅಲ್ಲಿ ನಮಗೆ, so in this axis the charge is moving with some velocity v. So z axis ಅಲ್ಲಿ move ಆಗ್ತಿದೆ, that means velocity and magnetic field both are perpendicular, then this charge experiences a force. So a force ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇರುತ್ತೆ ನಮಗೆ, it is always equals to x axis, in the direction of x axis, right? So because F and B are perpendicular, F and B are perpendicular. So ಒಂದು z axis ಅಲ್ಲಿ ಆಕ್ಟ್ ಆಗ್ತಾ ಇದ್ರೆ ಇನ್ನೊಂದು y axis ಅಲ್ಲಿ ಆಕ್ಟ್ ಆಗ್ತಿದೆ. So force ಯಾವ ಕಡೆ ಸಿಗುತ್ತೆ ನಮಗೆ, along the x axis. So here also the magnetic field is along y axis and the charge is moving in the z axis. So we consider this one as z axis, right? So the angle between the magnetic field and the velocity vector, that is 90 degree. So from this the force is acting inside, that means along x axis. So in this direction force is acting, right? So here consider a charged particle of mass m and charge q moving with velocity v. So ಎರಡು ಕೇಸಸ್ ಇದೆ. So first case ನ ಸ್ಟಡಿ ಮಾಡಿದ್ರೆ moving with velocity v perpendicular to magnetic field, that means v cross B. That means angle theta is equals to 90 degree. So B ಮತ್ತೆ B ಮಧ್ಯದಲ್ಲಿ angle ಯಾವಾಗಲೂ ಎಷ್ಟಿರಬೇಕು ನಮಗೆ 90 degree ಇರಬೇಕು. Then the charged particle will follow the circular path. So ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ inside the magnetic field the charge will follow the circular path. So if you consider this one as the charge Q, so it follows the circular path, right? So because the force is acting along x-axis, so this force acts as a centripetal force for this charge. So ಈ charge ಗೆ ಈ force ಯಾವ ತರ act ಆಗ್ತಿರುತ್ತೆ ಅಂದ್ರೆ centripetal force ತರ act ಆಗ್ತಿರುತ್ತೆ. So this again we can represent in this form. So ಇದು ನಮಗೆ 3 dimensionally picturization, so 2 dimensionally represent ಮಾಡ್ಕೊಂಡ್ರೆ, so cross mark indicates what the magnetic field is moving inside the plane of the paper. That means inside the board. So board ಒಳಗಡೆ ನಮಗೆ magnetic field pass ಆಗ್ತಾ ಇದೆ, right? So this is what the circular path. So circle ಇಲ್ಲಾಂದ್ರೆ circle ಅಂತ consider ಮಾಡ್ಕೊಳ್ಳಿ, right? So charge, so ಈ ಕಡೆ ಚಾರ್ಜ್ ಇತ್ತು ಅಂದ್ರೆ force inside and velocity v, because v and f again perpendicular, right? So ಈ velocity ಮತ್ತೆ ಈ force ಎರಡು ಏನಾಗಿರುತ್ತೆ mutually perpendicular. That means f, v and b, all these three are mutually perpendicular. So charge ಇಲ್ಲಿದೆ ಅಂದ್ರೆ so force ಮತ್ತೆ velocity always perpendicular, right? So again if the charge is here, so force is acting in this direction and velocity perpendicular to the force, right? So if the charge is here, velocity of the particle and force, so at any place the velocity v and force f, right? So this force is the magnetic force, right? So I will write f m, suffix m represents what the magnetic force when the charged particle enters the magnetic field which is perpendicular to that of the magnetic field. So charge move ಆಗ್ತಾ ಇದೆ ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಅಂದ್ರೆ perpendicular to the magnetic field, then it follows the circular path, right? So again from the relation F is equals to Q into B cross B, right? So that is the magnetic force. So this we can write QBB sin theta, right? So only returning the magnitude. So here when theta is the angle between B and B, so theta is theta is equals to 90 degree. So Fm is equals to QB. Calling this one as first equation, right? So now the charge is charge is following the circular path, right? So this is the charge Q which follows the circular path in the magnetic field. So circular path follow ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ again from the first year ಅಲ್ಲಿ ನಾವು centripetal force ನ ಸ್ಟಡಿ ಮಾಡಿದ್ವಿ, centripetal acceleration. So ಯಾವುದಾದ್ರೂ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಸರ್ಕ್ಯುಲರ್ ಪಾತ್ ಅಲ್ಲಿ ಮೂವ್ ಆಗಬೇಕು ಅಂದ್ರೆ so that is balanced by the force, so that force we call as the centripetal force. So ಯಾವುದಾದ್ರೂ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಸರ್ಕ್ಯುಲರ್ ಪಾತ್ ಅಲ್ಲಿ ಟ್ರಾವೆಲ್ ಆಗಬೇಕು ಅಂದ್ರೆ so one force act ಆಗ್ತಾ ಇರುತ್ತೆ, due to that force the particle will follow the circular path, right? So this magnetic force acts as a centripetal force, right? So centripetal force Fc, so Fc is the centripetal force that is given by m v square divided by r. So if r is the radius of the circle which is followed by the particle, where r is the radius which is described by the charged particle, right? So r is the radius, where m is the mass of the charge and v is the velocity of the charge and radius is the r is the radius of the circle, right? So calling this one as equation 2, right? So from 1 and 2 Fm is equals to Fc, right? So this magnetic force is similar to that of the centripetal force. So ಇಲ್ಲಿ magnetic field ಅಲ್ಲಿ charge circular path ಅಲ್ಲಿ ಮೂವ್ ಆಗ್ತಿದೆ ಅನ್ನೋದಕ್ಕೆ ರೀಸನ್ ಏನು ಅಂದ್ರೆ centripetal force. So charge circular path ಅಲ್ಲಿ ಮೂವ್ ಆಗ್ತಿದೆ ಅಂದ್ರೆ so that force is equals to the centripetal. ಇಲ್ಲಿ magnetic force, so circular path ಅಲ್ಲಿ ಮೂವ್ ಆಗ್ತಿದೆ ಅಂದ್ರೆ centripetal force, right? So equating 1 and 2 From this mv square divided by r, that is equals to qvb. So in the right hand side and in the left hand side, velocity get cancelled. So we can find the radius of the circular path r is equals to mv divided by qb. So this gives the radius of the particle which is moving in the magnetic field. External magnetic field alli charge move ಆಗ್ತಿದೆ, it traces the circular path means, so that circular path having the radius mv divided by qb. Right? So namge radius find out ಮಾಡಕ್ಕೆ ಹೇಳಿದ್ರೆ up to here we need to write the derivation. Right? So ಈ radius ನಮಗೆ ಚಿಕ್ಕದಿರಬಹುದು ಅಥವಾ ದೊಡ್ಡದಿರಬಹುದು, ಇನ್ನೂ ದೊಡ್ಡದಾಗಬಹುದು. Right? So that is entirely depends on the momentum. Right? So product of mass into velocity we call that one as the momentum. Right? So as momentum of the particle of the charge increases, the radius also increases. So this is one point, right? So because charge of the particle constant irutte, now apply madiro magnetic field kuda enirutte namge constant irutte. So the radius is directly related with the m into v. M into v call that one as the momentum. So p by qb, or we can write this one as q is equals to p divided by qb, where p is equals to the momentum, that is m into v. So momentum change andre radius change ಆಗುತ್ತೆ. So momentum ಜಾಸ್ತಿ ಆದ್ರೆ radius ಜಾಸ್ತಿ ಆಗುತ್ತೆ, momentum ಕಮ್ಮಿ ಆಯ್ತು ಅಂದ್ರೆ radius ಕಮ್ಮಿ ಆಗುತ್ತೆ. Right? So momentum ಯಾವಾಗ ಚೇಂಜ್ ಆಗುತ್ತೆ? velocity ಜಾಸ್ತಿ ಆದ್ರೆ momentum ಜಾಸ್ತಿ ಆಗುತ್ತೆ, velocity ಕಮ್ಮಿ ಆದ್ರೆ momentum ಕಮ್ಮಿ ಆಗುತ್ತೆ. That means velocity increase ಆದ್ರೆ radius increase ಆಗುತ್ತೆ, velocity decrease ಆದ್ರೆ radius ಕೂಡ decrease ಆಗುತ್ತೆ. Right? So this is when the charge is moving perpendicular to that of the magnetic field. That means angle theta is equals to 90 degrees. Right? So circular path ide andre namge again time period barutte, frequency barutte. We need to calculate those two relations also. Right? So angular frequency, angular velocity. Angular velocity, because it traces the circular path, we are getting the angular velocity. Angular velocity is denoted by omega. Right? So omega is equals to v divided by r. Right? So omega is equals to v by r, or linear velocity is equals to omega into r. So this is the relation for the angular velocity to that of the linear velocity. Linear velocity means this velocity, tangential alli hogta iro velocity na ನಾವು linear velocity ಅಂತ ಕರೀತೀವಿ. So circular path alli ಹೋಗ್ತಿರೋ velocity na angular velocity ಅಂತ ಕರೀತೀವಿ. Right? So tangential alli ನಾವು ಯಾವ velocity draw ಮಾಡ್ಕೊಂತೀವೋ that is always linear. Right? So circular path alli ಏನು velocity ಇರುತ್ತೋ ಅದನ್ನ ನಾವು angular velocity. So relation for angular velocity to the linear velocity is omega is equals to v by r. Right? So from this equation we can take the v by r value. Right? So v then r, so we can write v by r, that is equals to qb divided by m from this radius relation. So substitute this value here, we get the angular velocity omega is equals to qb divided by m. So this is the radius of the particle traces the circular path. So this is the angular velocity. Right? So from this angular velocity we can find the frequency. Right? So we know omega is equals to 2 pi f. Right? So omega value is qb divided by m, that is equals to 2 pi f. Right? So from this frequency, that is qb divided by 2 pi f, number of revolutions made by the particle in 1 second, so that we call as the frequency. Either it may be 10 rotations, 10 revolutions, 50 revolutions. So ಎಷ್ಟಾದರೂ revolutions ಮಾಡಲಿ in 1 second ಅಲ್ಲಿ, so ಅದನ್ನ ನಾವು ಏನಂತ ಕರೀತೀವಿ? Frequency ಅಂತ ಕರೀತೀವಿ. Right? So next one is the time period. So time period t is defined as the reciprocal of the frequency, that is 1 divided by f. So f value ಗೊತ್ತಿದೆ, so substitute ಮಾಡಿ simplify ಮಾಡಿದ್ರೆ ನಮಗೆ 2 pi m divided by cubic. So this gives what the time period. So time taken for complete one revolution. So one revolution ಗೆ ಎಷ್ಟು time ತಗೊಳುತ್ತೆ, that gives the relation t is equals to 2 pi m by cubic, right? So ನಮಗೆ three relations, radius ಆದ್ರೂ ಕೇಳಬಹುದು ಅಥವಾ time period ಆದ್ರೂ ಕೇಳಬಹುದು. So ಇವೆರಡು ನಮಗೆ ಗೊತ್ತಿರಬೇಕು. So ಇವೆರಡು ಗೊತ್ತಿದ್ರೆ ನಮಗೆ time period ನ ಡಿರೈವ್ ಮಾಡ್ಕೊಳ್ಳೋದಕ್ಕೆ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ, right? So 3 marks ಗೆ important, either they may ask for the radius or for the time period, right? So in the next class we will discuss the second case when the charge moving other than 90 degrees, that is moving some velocity which is other than 90 degree with the magnetic field. So some angle theta, right? So some angle theta, either it may be 60 degree, 30 degree or 10 degree. So ಯಾವುದೋ ಒಂದು angle ಅಲ್ಲಿ magnetic field ಅಲ್ಲಿ entry ಆದ್ರೆ so ಅದರದ್ದು shape path ಏನಿರುತ್ತೆ ಅನ್ನೋದನ್ನ discuss ಮಾಡೋಣ. So that we will discuss in our next class. Thank you.